So my name's Tom Tabor, and I am not going to use the word pedagogical anywhere in this talk. So I know that I'm in a room full of engineers and geeks now for sure. So I want to talk to you about WIKISPEED today and what we do. We actually build fast, efficient, safe, fun, sexy vehicles that are hoping to change the transportation industry forever. And we do that in a number of different ways that I'm going to talk about today. So we look at manufacturing, and we look at the way that traditional cars are built. We see this standard mainstream hybrid automobile, and over a 6-year period, it's gained 2 miles per gallon in efficiency. And that's really its main selling point. So it's kind of amazing. Why is that? Why aren't things happening faster? Why aren't things evolving even faster than we see them today? And a big part of that is with the way we see that how manufacturing actually works. If an engineer has an idea tomorrow of how to really make a door incredibly safer, incredibly better, they can't do that idea for 10 years after they've made the initial one, because it takes that long, at least that long, to recoup the cost of building the dies, of putting the process in place to actually produce that door. And so we see that as an impediment to actually moving forward quickly. If we look at the way manufacturing works, it works a lot like old software teams back in the mainframe days with punch cards, that sort of thing. You had these teams that gathered all these requirements for a whole software system, and they were laid out in like extreme detail with these big, thick binders. Then they went through this whole design process. The implementation took months or years. Verification and testing could take more months or even years also. And then finally you go into a maintenance cycle, which slowly just carries the system forward. And then maybe eventually you have to start all over again because the software is already obsolete by the time it goes live. So we see that we don't really want to follow that model. We want to really follow the model of Agile teams, the way new software teams work, which requirements are gathered quickly based on today's current needs. Design happens quickly. Implementation is fast. Getting that first solution out there quickly and then improving upon it, verifying as you go, and the maintenance is really an ongoing process of redesigning all the time and improving over time on a 7-day cycle. So implementations are in a 7-day cycle, and every week we're looking to what we can do to improve the whole system, and that's how we run our organization and manufacturing as well. So how do we get started? Where was our start? Richard mentioned Joe Justice. So this is our founder and CEO, and he's a pretty interesting guy. So he has a number of passions in life. One of them is software. He's a complete geek, to be honest, and a lovable geek at that. He's also a huge car nut as well, and really concerns about the environment. So he does things like goes out and camps in the wood with minimal things, for instance, and has just a real love of that. So this kind of collaboration of all these things came together in Joe's life and caused him to start a car company. Now, pretty strange for one guy sitting in his home deciding, I want to start a car company all by myself. But he had, by chance, some luck in doing that. He actually knew all the regulations and what it took to actually register a car company and went through this laborious process and was able to do it. So actually one of the few people in this country that actually owns a registered car company. And he did that really because he had a love of racing. And he had done a lot of racing back in college. And he found that with racing, one way to get cars to go faster is to add more horsepower. And you add big engines, that sort of thing. But Joe found it interesting that you could actually increase the speed of cars by lightening the weight. If you could lighten the weight, still keep them safe and strong, you could actually make a better race car. And so that was really one of his interests in kind of starting this car company. But then something changed and happened. Progressive Auto Insurance announced that they were going to be the sponsor for the Automotive X Prize. If you've ever heard of the X Prize, it's a contest that actually looks to change something in technology for social good. So actually changing the way that industries are doing things. And one of the first X Prize, or the first X Prize, was trying to get a commercial spacecraft into orbit around Earth. And so that was a successful project. So Progressive said, we want to do the same thing with automobiles, but we want to build 100 mile per gallon commuter cars that people will actually want to buy. And they're willing to put up $10 million prize money to do that. So Joe said, great. I'm actually most of the way there. I already have light, fast, safe cars. If I could just make them fuel efficient enough, I could really be in the running for this contest. Now, at the time, there were 100 mile per gallon cars in 2008, but they kind of looked like this. They weren't really what commuters wanted, and they weren't really road legal safe. They were kind of bobsleds on 10-speed wheels. So that's not really what Progressive wanted to do, and that's not really what we wanted to do either. So Joe started blogging about his ideas online and started attracting a lot of people to what he was doing. So he had questions like, how do I make a handbrake that's going to pass the requirements of this vehicle, but also not significantly impact the rolling resistance of my car? And there's people that stay up late at night thinking about this that actually want to respond to such blogs, and they did. And so he attracted all these volunteers that were said, hey, we have some great ideas of how you should do this, and they started helping out online, but they also physically started showing up to help turn wrenches and actually build stuff. And so by the time the X Prize came around, our team had grown to 44 people in a number of countries around the world. And in 3 months, they quickly put together this car that we lovingly call the shoebox, because it's not necessarily the most beautiful car in the world, but it was highly efficient and actually aerodynamic. The front nose cone is actually a NASA-designed airfoil that's actually very highly efficient. And there was over 100 teams in this contest. Many of them were famous car companies and famous universities with tens of millions of dollars backing them up. Well, Joe kind of had his team of volunteers and his down payment he was going to use on a house for him and his wife, but instead put to the X Prize. So a much less funded organization, very much a grassroots thing. And at the end of it, we had outlasted 100 other teams and came in 10th place, tied in 10th place for the X Prize, which didn't win us the $10 million, but it did give us a lot of exposure, a lot of great press, and a lot of momentum for moving forward. And this is kind of what the car looked like underneath. We built a really modular, efficient design, and it was able to change it very quickly, and that really helped us in the contest, and it helps us continue to build interesting cars today. And we've iterated that over the last couple of years since the X Prize, and now we're actually building cars that are much prettier than the shoebox, and something that consumers would actually want to purchase and drive around. So we're excited about where this has all led so far. And we'll talk about the iterations that led us to that, using Agile, Lean, and Scrum, which are these crazy terms in the software world, but we actually use them in our manufacturing as well. So the first one is modularity, this concept that things are modular. And this, for all the software folks in the room, modularity is encapsulating functionality. So for a software function, it's a piece of code that you input parameters into. It does some stuff, and then it spits out a result on this side. So it encapsulates just this one thing very well. We take that same concept to pieces of hardware as well. So there's different parts of the car that are systems unto themselves that don't rely on other parts. The suspension is bolted onto a plate that then bolts into the chassis, and that suspension can be switched out from McPherson struts to double wishbone or whatever other types of suspensions you want. The engine module is an aluminum box that holds a drivetrain within it. Now that drivetrain can be a number of things. Currently we're using 1.8 liter Honda Civic gasoline engines, but it could be a hybrid engine. It could be a natural gas engine. It could be a fuel cell. It could be a green jello powered amazing efficient thing that we never thought of before. So it can be whatever it is, put it in that one part of the car, and the rest of the car doesn't have to change to accommodate that major change in that one module. So encapsulating functionality, having it so that it changes out quickly. We can actually pull that engine module out, unbolt it, and put a new one in about 10 minutes or so, about the time it takes to change a tire. And this really helps us out in the X Prize. So during the X Prize, at the end of it, or towards the last days of it, we had some rule changes. And these rule changes were kind of devastating to a lot of teams. They had things that you had to change about how the car worked or how it had to pass different regulations. And at the last moment, we actually disassembled the whole car into pieces, carted away overnight so we could actually make these modifications, welding, changing electrical systems, re-drilling things and bolting things in different places, and came back the next morning and essentially built the car from the ground up in a matter of hours. And the teams around us were looking in shock. Some of them had to drop out right then, but in a number of hours just before the deadline, we got the car all back together, and we had a standing ovation from all of our fellow competitors there. They couldn't believe they actually put it back together in time. And it was a huge accomplishment for us, and really a great moment in WIKISPEED history. So we use a number of concepts, as I said, from the software world and from the manufacturing world. One of our core concepts is using lean. And lean is essentially the common sense idea of just using less stuff. But Toyota is one of the companies that took this idea and made it into a business process. And what it's really about is delivering customer value at all cost. So finding those things that need to actually build values for customers and cutting away all those things that impede you from doing that. And so in this case, we have Rob Huggins, one of our recent high school grads, who's part of our team, does a lot of work with us. He's using a $90 bandsaw to cut this aluminum extrusion. So this is a square tube of aluminum, very strong, 6061 T6 geeky aluminum, that's stronger than steel per weight, that sort of thing. And he's cutting this chassis to build, or cutting this piece of aluminum to build a chassis. And in the regular auto manufacturing, this would be a several $1-million machine to do this process. We're using a very inexpensive and low-cost way to do it because it meets our needs at this time. In a higher production environment, we'll probably have to upgrade to something bigger, but right now this meets the need for what we're doing, and that's how we do things. Do what works today and upgrade only when you need to. We also use Agile. As Richard mentioned, that it's also Agile is a core concept of how we do things, and it allows us to make change quickly. So when we're doing our business, which is building cars, sometimes new requirements come up. And as those new requirements come up, we still have our goals in mind, but we can switch goals if there's a short-term goal that we want to accomplish. So just this last week, we had one of our team members, Anissa, she heard about this contest, this film contest, and it's for short films that are about grassroots organizations that are using technology to change the world. She said, wow. This looks like this contest was made to highlight WIKISPEED, and I really want to do a film. And she, as a student, has experience in that. So she put out a message to our email to our team, said, hey, I want to build a short film on WIKISPEED. Does anybody think this is a great idea? A number of members raised their hand and said, yes, we want to help you out with this. I think it's a great idea. There's a 2-week deadline to it. So she's working very quickly to get this film done. And this was never on our radar before. So would a normal organization just say, well, it's too late, we've already passed that? But our organization says, well, we have self-organizing teams that are motivated to do things, that have the skills to do them. We don't have to have a mandate from up above to say, here's what you're going to do. We can actually have people do things naturally, what they're called to do, that actually help and benefit the organization. Just kind of a no-win, no-lose situation here. Anissa's going to get a great film out of it. She's going to get great experience from that. WIKISPEED's going to get great exposure. And we don't know what the end result will be. Maybe we'll find more volunteers, investors, or buyers for our cars from the videos. So I'm really excited about what that can do. And that's just one example of how we agilely respond to new opportunities in our organization. I know a number of you are familiar with Scrum, and it's this word that comes from rugby. But in the technology world, it's actually a way of managing teams and organizing teams. So we use Scrum as a way to maximize creative problem solving. And it's essentially about stripping away all those things that are standing in the team's way to actually meet their goals. And one way we do this is we have a weekly meeting, a weekly online phone conference of all the team members in WIKISPEED. It's about 150 people around the world right now. And we call in and we say 3 things. We have 1 minute. Each person says what they've done this last week, what they're going to intend to do in the coming week, and any blocking issues they have. At the end of the meeting, we kind of go through all those blocking issues and see if there's other team members that can help unblock those issues. And so it's a really creative way to have teams move forward and do things. Simplicity is core to what we do as well. And we have simplicity as a concept of not just making things simple for simplicity's sake, but simple in terms of elegance, stripping away all those things that are unnecessary and keeping just those core elements that are essential for delivering customer value. So simplicity can be a number of things. One example is the front crash structure for a vehicle. Originally we used a crash structure that was built by another car manufacturer. It had this curved shape to it. It was really complex. We knew that it needed all the road legal standards, and it was very expensive and actually heavy. So we looked at it, we said, okay, we could continue to use this, or we can actually design our own. So we went to our team, went through an engineering analysis, ran it through some simulated test modes, and we actually developed our own crash structure using aluminum extrusions and creating a crumple zone that collapses in stages. And we were able to build something that was actually simpler, lighter, and cheaper than the original one that we built. And so we were always looking for solutions like that, ways that we can do things simpler, cheaper, safer, faster. So it's a great way, just an example of how we have simplicity and embed it in the things that we do. Visibility is a huge concept for us as well, and visibility is really transparency. Transparency of how our organization works, transparency of what we're doing at any given time. And another example is just transparency of how our shop is laid out. So if you come to our shop, or one of our shops in the world, you'll see they're kind of laid out in a similar way. In the back wall, you're going to see there's actually shelves, and in the shelves are clear bins. And it's intentional that we have clear bins so you can actually see what's inside of those. We have it organized in a very logical way. We have our hand tools next to our power tools, and our power tools are next to the supplies for power tools. So if we have sanders, for instance, or drills, we have the drill bits and sanding discs right next to those. So if you're new to the shop, or if you're new to this particular shop, you can go in and you can quickly see, okay, I kind of see how this is laid out. If I suddenly need a hammer, I'm probably going to go over to the hand tool section and grab that. And it's just a very logical way it's laid out. We also have kind of our minimum requirements for a shop. And we recently built a very impromptu shop at a conference, and we had to have these 3 essential things. One of them is a Kanban board, which we're going to discuss shortly. Another one is a safety shelf. We always have to have our safety supplies, goggles, face masks, gloves, those sort of things. And then we always have to have a snack shelf. So the snack shelf is to have protein bars and things like that, some water, because making sure that we have team morale is our biggest goal. Having morale is a multiplier for velocity. If we have people that are happy with what they're doing, they can do a great job and do it even faster. Visibility is also our online presence as well. So since we're a distributed team around the world, a lot of what we do is online, actually collaborating virtually. And a lot of the tools we're using are things that come from companies that didn't even exist 10 years ago, and tools that weren't even available as little as 5 years ago. And many of them are free. Without these tools, we really couldn't do what we do today. An example is we daily have Gmail email that goes out to our whole team, and people ask questions, respond to it, present new opportunities. We're weekly creating new YouTube videos about what we're currently doing, our current state of things, or even questions, or this presentation will be another YouTube video on our site, wikispeed.com. Our conference calls we have on a weekly basis, I mentioned, we do that through freeconferencecalls.com. So it's a lot of collaborative tools that really make what we do, enable it and make it possible. One more thing that we borrowed from the software world is from extreme programming, or XP. It's this concept of pairing and swarming. And pairing is, a programmer can actually go out there and write programming code all by themselves if they want to, and many programmers do, but they found in extreme programming, if you actually pair with somebody else, you actually have somebody that's going to be a mentor, or you can be a mentor for somebody else. You can share knowledge. Actually, code gets written more quickly and gets written in a better, more documented sort of way. And so we use pairing to a number of ways. Here we have Kurt Roy and Martin are actually working on an engine, and they both know about engines, but by working together, they actually get the job done faster, and they're sharing knowledge between them. This keeps us from having to document exactly how to do things. Instead, we're sharing knowledge human to human, and we're also sharing it through our YouTube videos. So it's a way of actually creating more velocity in our team and making it more fun to actually do the work, because it's always more fun when you're working with somebody else. Swarming is the concept of getting a whole team to tackle a problem at once. If we have a huge blocking issue, and we had this a couple of months ago, we have a wiring harness in the car, and if you've ever seen an automotive wiring harness, it's essentially miles and miles of colored copper cables that are all bundled together, and it's a complete rat's nest. It's actually horrible to look at if you're an electrical engineer. And we had a short in that wiring harness somewhere. So it was a task that nobody individually wanted to tackle because it was so daunting. But we actually took a whole night and said, okay, we're going to find this thing. We had the voltmeters. We had just checking it visually inch by inch. And by swarming on it over one night, we actually found the fault. We were able to repair it quickly and move on to the next thing. And so it actually unblocked this thing that had been holding us up for a couple of weeks. And it was a great way to solve that problem. Trust is another huge part of what we do. And this is an interesting thing, because in a lot of organizations, trust is something hard for organizations to actually do with their people. And you'll see this show up in a number of different ways. There's rules and regulations and codes of conduct that people have to follow and abide by. There's very strict regulations of what you can and cannot do. There's just very insidious ways that the organizations don't trust people. And we take the opposite approach, that we implicitly trust anybody that walks into our door. That we know that people want to do a good job. The reason they're coming there are because they want to make a difference in the world. And we trust that they want to do a good job. So that when you actually get a task, you take a task from our task board, and you can pair with somebody else that actually may or may not know more or less about it. If you feel like you know everything you need to know about it, then you can go for it. If you don't, get with somebody that knows a little bit more about it and actually work with them, partner with them, and do that job. So trust has been a huge thing. For me personally, working with WIKISPEED, I got the chance to actually design chassis. So I get to actually explore my engineering side, and using Google SketchUp, got to create these 3D models of new chassis design ideas I had. Now, in order for those designs to actually become a reality, they have to go through extensive testing and verification to our engineering department, that sort of thing. But I was actually able to do things that any normal organization wouldn't really let me to go off and play and do, and it's been incredibly exciting to do. Kanban board is this interesting thing. It may just look like a whiteboard with a bunch of Post-it notes on it, but it's actually a whiteboard with a bunch of Post-it notes on it. And how it works is, on the left-hand side is these things that are tasks to actually be accomplished. In the middle are things that are in progress, things they're working on. Followed by that is things that are done but need to be verified, and then completed and done are off here on the right-hand side. And it's a very simple thing, and that's by design. It actually helps us prioritize our tasks. Very simply, we know that we have to accomplish these certain things the next day or the next week or the next month, and those go on the Kanban board, and they're listed with the highest priority items at the top. If you come into the shop, you can see what are the highest priority items, and pick the one that actually excites you, interests you, and you have the skills to do. Pull that off, put it in progress, and start working on it. As you work on it, you can get help from other people. As you complete that task, you put it into testing, somebody comes and verifies it, and then it goes into the done pile. And when it gets to the done pile, it's this amazing thing. You can actually see how you've actually accomplished things. This initially was full of all these Post-it over here, and now they're over here, and we can actually read off the list and see, here's our accomplishments for this day, for this week, for this month. And it's a powerful way to organize it. Since we're an online organization as well, we have an online version of this using scrummy.com, and it's an online version of this whiteboard and Post-it notes. And so it's a way of us to kind of look at our whole project as a whole and see what's happening and what's going on, and very powerful. In fact, some of our team members have liked this so much they've actually taken it into their personal lives. So I've seen people actually packing for a trip, turning a mirror into a Kanban board just to make sure they don't forget their socks, that sort of thing. Also, people taking it into their day job where they're not working in an agile environment, but they needed a Kanban board because the tasks were so complex and so daunting, they just needed to organize it for themselves so they could see how things were going. And when other employees saw this personal Kanban board, they said, "Oh my God, you have so much to do. Can I help out? Can I also take on one of these tasks?" Like, no, this is fine. This is just for me to make sure that I'm doing the right things. And it's a powerful tool for doing that. So all these concepts, all bundled together, are something we call extreme manufacturing, or XM. And it's this concept of what WIKISPEED is really promoting, that taking these concepts from software development and applying to manufacturing as extreme manufacturing. So all those things bundled together really encapsulate or describe that sort of mindset. And we're going to push that out to other organizations, as we'll talk about in a moment. I first want to go through a case study, though, of how we build aesthetics at WIKISPEED, or how we actually iterate our vehicle over time. And you may have seen that there's this vehicle that looks like a Le Mans racer. It actually is a car that we built for a car show. We started with a CAD design. We started with a CAD drawing, and that's how things typically start whenever we have a new design. Now, we needed to build this car for a car show, and we only had a few weeks to do it. Now, traditionally, it would take about 4 months and $30,000 to build a car for a car show. Even longer than that, possibly. But in this case, the way we wanted to do it was going to take that much time. We had to find a way that was creative and did it in a shorter amount of time with less amount of money. So we took our CNC drawing and actually created a block of foam using a CNC machine that just carved it out exactly to the exact specs of that drawing in about a day. Then we sanded that down, smoothed it out, and then in one more day, we actually laid carbon fiber over it. Now, this process in total took about 7 days and cost a total of $800. So it was a huge disruptive way that we were actually doing this. We could only really use this mold once, but we built the one car we really needed for this car show. And we built it in a way that was extremely light, extremely high-tech, and extremely strong. And we took it to the world's largest car show, in actually Detroit, Michigan, the North American International Auto Show in 2010. And we actually displayed it on the main show of the floor, right between Chevy and Ford. And fortunately, it was a beautiful vehicle, and we were very proud of it. It was much, much better than showing up with our orange shoebox. That may not have impressed anybody. But having this vehicle really said, okay, here's this technology that's super light, super efficient, modular, all these other things I've talked about, and it comes in this gorgeous car as well. And it gave us a lot of press. Internationally, we got a lot of press in various magazines, from everything from Forbes to Automobile magazine, which is one of the more conservative automobile magazines out there, but they created an article on us called Above Average Joe's Can-Do Car Company. And that was just a huge leverage for us to go on and do other things. In fact, we got a call from Discovery Channel magazine, and they wanted to do a documentary on us. So they came out and filmed a whole documentary on exactly how we do our processes, the whole story of WIKISPEED, and that even gave us greater exposure and greater press. Then we took the lessons we learned from that, building that foam block, and we built another foam block, but this time building a convertible commuter car, something that people would actually want to drive. And instead of building one that we could just pull one mold out of, this is a production quality mold that you can actually pull 200 vehicles out of. And so it's a little bit more laborious process. It took about 8 months to complete. And this man, Rob Moorbacher, in our Maryland shop, pretty much did most of the work all by himself. He's kind of a genius with CAD design and with composites. And then we launched a crowdfunding campaign. So this is, you may or may not know that this is kind of the way a lot of startups are actually getting funding now, is going out to the internet and showing their story and getting people to say, hey, I love what you're doing. I want to invest in you, even in small increments, and quickly getting a lot of money. So instead of explaining our crowdfunding campaign, I'm just going to show you the video from it.
This targets 100 miles per gallon. This car is completely modular from the body down to the engine. Transforming from a two-seat convertible to a four-seat family car to a pickup truck. We've been the plans to build this car completely free of public online, and this car is fast. Introducing the world's first gas-powered 100 miles per gallon sports car, available open source to the public.
I'm Joe Justice, the team leader of Team WIKISPEED. This carbon fiber knitted convertible ride aluminum extruded chassis supercar is $25,000. It's a race car. It's extremely basic. We're not running the gap to bring as much of that technology as possible, as much of that sport racing performance, and most importantly, ultra efficiency in an even lower cost package that's a comfortable commuter car for people to enjoy every day on their way to work. We want to bring this incredibly efficient technology to your driver. Our goal is to make the next model of the WIKISPEED car a realistic option to save you big bucks at the gas pump. Team WIKISPEED runs on materials, machinery, and personnel. Funding allows us to turn all those resources up to 11. We want to complete 10 additional crash tests. Also, additional fuel economy testing that's certified by the EPA. Our project is funded for the people that buy it. Your support is going to bring the 100 miles per gallon revolution to drivers all over the world. We are going to be a part of action, helping the world completely awesome. Let's drive WIKISPEED.
So that was our crowdfunding campaign, and it actually did a great thing for us. It brought in some money, enough to actually do another physical crash test, which is an expensive proposition and something that we like to run on a regular basis. So we're hoping to do more of these and really like that initial success from it. Then we had one other great success just 2 months ago. Joe was invited to be the keynote speaker at the Agile 2012 conference in Grapevine, Texas. And so as part of that, we actually unveiled our latest vehicle, our convertible commuter car. And talking about agile processes, just getting this car to this venue was an agile process all on its own. In fact, it was actually still inside the mold when the conference started in Maryland. And so it had to be taken out of the mold, crated up, and shipped to the conference. It got there mid-conference. We unboxed it, and then actually had conference volunteers come and be volunteers to actually build the car so we could actually put it on stage. So backstage, we actually had about 30 people turning wrenches, bolting on suspensions and tires, and polishing down this whole body, applying the adhesive stickers to it as well. And so we actually had our unveiling of our first commuter car there just 2 months ago, and really exciting thing to do. So that was our whole case history on just our iteration and our process of where we've been with our vehicles in terms of aesthetics. But let's talk a little bit about safety also, and just give another example of how we're using Agile to move safety in our organization. So one of the things that we always do, we start with a test-driven development. So we first define the test that we want to pass and succeed on, and then we look at how we can actually meet that test. And so in this case, it's the NHTSA side impact test. And to do that, we start with a computer simulation or computer model. And so we run our chassis design through that model. It gives us information and feedback on where we're strong, where we still need to make improvements, that sort of thing. And then every so often we actually want to run a physical crash test. So we run that crash test to give us real world data and calibrate that computer model and tell us, okay, where do we need to still make further improvements? Where can we even make the design even better? And it's similar to what a normal car company would do as well, a major manufacturer as well. So that actually gave us some information that we needed to increase the impact resistance on our side impact. And so we took it through another design iteration and came up with a simple, elegant design using aluminum extrusions. And this is a father-son team that is in our shop just weeks later installing that new solution to one of our chassis. So that design process of iterating, getting new information, and improving the design is something that we do in all parts of our car, but this is just one example of doing that. So I've talked a lot about cars and building cars, but WIKISPEED's a lot more than just the cars we make. We're actually about the processes we use to make those cars, the way we organize our team, the way that we actually apply our principles to both the way that we design manufacturing, but also doing social good for the world as well. And so as part of that, we reach out to other organizations. And one of them was mentioned in the crowdfunding video, Open Source Ecology. So we've been working with this group. They are an organization that's dedicated to building the 50 machines that are necessary to build a global village from the ground up. And so this is an example of the tractor they built just using locally sourced materials, not using any pre-manufactured parts. And they've also chosen the WIKISPEED card as their automobile for the 50 machines to build a global village. And as part of that, we also took our designs and made them open source online. So we're really happy to be part of this organization and the things they're doing. And we're both influencing each other in how we do business. Then this little company called John Deere in Moline, Illinois, they called us and said, hey, we really like what you're doing with manufacturing. We wonder if we can actually use some of those same principles in us. And John Deere's been around for 175 years, so they know pretty well how to make a tractor at this point. They know what they're doing. They do a really good job at it. But one of the things they were struggling with is the time it took to develop those products and meeting them on budget as well. And so they said, if we can actually employ some agile practices, we think we can get greater efficiencies in the time to delivery and product quality. So we actually worked with them, and we've introduced some agile practices of putting Kanban boards in their teams, actually having stand-up meetings on a weekly basis. Doing some of these practices we're doing in WIKISPEED are now happening at John Deere as well. Then we got a call from another little company locally here called Boeing, who is pretty amazing at what they do as well. They build the finest aircrafts in the world and just released their 787 Dreamliner as well. And that's the highest tech airplane they've ever built to date. But it was also 2 years late. So they were interested in how can we use Agile to increase the productivity of what our teams do and do them even better. And so we went out to their facility and they showed us around what they do. And then a group of their CEOs came out to our facility to see how WIKISPEED did it. And this is a great way for our two teams to collaborate and actually exchange ideas on how you can use Agile processes in manufacturing. They're a very large organization. We're not going to change them overnight and wouldn't even attempt to do so. But the conversation started, and we hope to see more of that happening within their organization and continue to work with them. Then we went down to New Zealand to this great little company called Tate Radio. And Tate Radio builds two-way radios for emergency responders, firemen, police, that sort of thing. And they're really one of the best in their industry about what they do. But again, they wanted to increase the speed to market of the products they build. So we locked 3 other teams that really only tangentially worked with each other previously to this for a week. So we said, okay, you guys are now a Scrum team, and you're actually going to all work together as a cross-functional team. And we know that you have your defined jobs, but instead of those assigned jobs, you're actually going to work together to create the greatest product you can in 1 week's time. And so we had the marketing team in there, the product team in there, and the embedded systems team in there. And they'd never all worked together this closely. Before, they'd have to send off an email to somebody, and it may take a day or a week to get a response. Now that person's standing right next to them, making the decision with them, and the time to make decisions was just incredibly sped up. And at the end of it, after 1 week, they actually had a viable product. They'd actually built a prototype for a proxy customer that was actually a working model. And they had never done that in their company's history before. So they're very excited that they were able to do it and build something that was actually exactly what customers needed. So they're going to implement these practices in their daily systems, and they're actually taking on Agile practices now and applying it to their manufacturing and development processes. We got contacted by MakerPlane. This is a group of aviation geeks online that are building do-it-yourself airplane kits. And it's just kind of really cool stuff. And they really like what WIKISPEED does, and they also like the processes that we use. So they've adopted the WIKISPEED methodologies of Agile, Lean, and Scrum to produce open source documents on how to build your own plane. So we're excited to be associated with them as well. But a big part of what we do in WIKISPEED is education as well. And we do formal education, we do very informal education. If you come to a WIKISPEED shop, you may do something you've never done before. You may have never actually turned a wrench on a motor before. You may have never done a social media campaign before. You may have never built a film before. Whatever it is, you can come and learn so many different things by working with WIKISPEED. And we have people doing it all over the world. As we mentioned, we're in 16 different countries now. Actually, our newest shop is in New Zealand. Some of the group from Tate Radio really liked what we did so much, they decided to build a WIKISPEED shop in New Zealand and start producing WIKISPEED cars in New Zealand. So they're our newest team, actually. We do distributed education. As I mentioned, we use extensive use of YouTube, and one of our prolific YouTubers is this fellow behind the camera here, Rob Beersford, and he's a former educator and a person who actually helps talk and teach our interns that work in our shop. And here we have one of our interns, Quan, who spent a month with us and actually lived in our shop and worked daily in our shop, filming him. And they're doing a video on some process to finish off a piece of aluminum extrusion here. But we build videos like this on a weekly basis and have them up there. This is one way that we communicate and document what we do with our whole team. Another fellow on our team is named Alex Rosales, and he's the tall fellow on the left here. And he's a Spanish man, but lives in Ho Chi Minh City, Vietnam. And he's been a one-man force of nature of building WIKISPEED Vietnam. And he's working at the local university there, the Ho Chi Minh University of Technology, and implementing WIKISPEED as part of their curriculum in their universities. They're actually building vehicles as part of the engineering program at the university there and teaching students real-world experiences of how to do that. Also as a feedback loop into improving our processes and our vehicles, and with the hope of actually building WIKISPEED vehicles in Vietnam for the Vietnamese market or perhaps the international market as well. So we're excited about everything that Alex is doing and hope to replicate what he's doing in other parts of the world. This fellow, Emre Aras, is a student from Turkey, and he came to the United States on a one-year Fulbright scholarship, working locally here in Seattle. And he spent 3 months with us in our WIKISPEED shop, actually improving our engineering of our electrical systems there, and then came to Agile 2012 with us and was part of our presentation team there. He's back in Turkey now. This is him at the university there working with an Arduino open source electronics board. And so he's one of those guys that knows all the great stuff we really want in an engineering student. He studies electrical engineering, mechanics, robotics, composite systems, and he's just kind of a one-man wonder kid. So we're happy to have him as part of our team, and he's continuing to work with us remotely from Turkey now. So this is a bed and breakfast in France, and this may seem like it's not related to any of this, but it actually is, because this is where Peter Baines lives. He's an Englishman that lives in France and runs a bed and breakfast with his family there. But in his spare time, he's an Arduino programming guru. And he does this as a side job, but he also donates a lot of time to our team to develop the next generation of our electronic systems for our vehicles and heads up that whole programming team from France remotely. And we'll do things like send Peter an actual pedal from our car, which is both the pedal and the mechanical electronics part of it as well, and he'll test that out with the electronics components he's building there, make sure it works and passes all the tests, ship the whole thing back to us so we can actually install it in Seattle here and get road-worthy testing on it. So it's a great way of collaborating internationally, both not virtually on, but also with physical products too. These are two of our interns that worked with us last summer. Shane on the left is a student in robotics and composites, and Ray on the right is a student from Michigan that came out and spent a month with us in our shop working on a daily basis and documenting our system through CAD and also iterating our car and making improvements on it on a daily basis. And they were able to get class credit for the work that they've done. So this is just another example of how we can work with students in education. It benefits the work they're doing in their university settings, but also helps us make major improvements to our processes and cars. One of the things I do at WIKISPEED is I answer the phone. So if you call WIKISPEED, I might be the guy that answers. And one day I got a call from this lady, Susan Tatsui Darcy. And she's a counselor at the Merit Academy in Santa Cruz, California. And they have this amazing program for high school students called Kids for Hydrogen. And last year, the high school kids built, I call them kids, but these are really very smart high school students that probably know more about engineering than I will ever know. And they actually built a fuel cell from the ground up, all by themselves. This next year, they want to actually build a WIKISPEED car and build the first fuel cell-powered WIKISPEED car. So taking that engine module and installing a fuel cell engine in it. So we're excited about what they're doing, and we're working with Susan and her students to move this whole thing forward. In fact, Susan and two of her students, the two at the top here, they flew out to Agile 2012 just to meet us and have dinner with us. But unfortunately, things at WIKISPEED are pretty agile. So instead of having dinner, we first put them to work, and we created a sidewalk WIKISPEED shop. And you'll see the clear bins on the sidewalk there kind of lined up, just part of our standard. And they actually broke down this car in about 100-degree heat and 90% humidity. And we're a great part of the team because we had to break down to put it back in the trailer to bring it back to Seattle. So then we went and had great barbecue after that. But they got some really great hands-on project experience in the process. So final thing, just talking about WIKISPEEDs and schools. It's something that we're very interested in and committed to. We would like to see more students being able to get class credit, working with more schools to give class credit for working with WIKISPEED. And we see this as a way of giving students hands-on project experience with something that's more than just a semester-long project, something that actually has a life and can actually impact and change the world in a positive way. So having a lot of school projects that deal with automobiles that either last a semester or a year or just 2 years, and then those cars are usually shelved off to the side and we never see or hear from them again, which is an unfortunate thing. By working on WIKISPEED, they can actually be working on a project that's open source, that's actually changing the world in a way that's building 100-mile-per-gallon cars and highly fuel-efficient cars that has commercial viability as well. And so we see that as a huge positive for students and for ourselves. We'd like to see WIKISPEED, building a WIKISPEED card more as part of a curriculum in more schools as well. So actually as part of a shop, a design, or project management courses. And any way that we can do that, kind of what we've built with the Vietnamese crew and also with the school Merit Academy in Santa Cruz. And finally, we have this idea of building an ultra-affordable race. And this race isn't necessarily racing cars, but it's actually building modules of cars and competing against them and having those modules be part of what WIKISPEED actually produces for customers. And maybe someday we actually are racing actual WIKISPEED cars out on track and using those improvements, not just for speed, but also for efficiency and meeting whatever other goals that we actually want to accomplish. So that's a lot of what I want to talk to you today, but I want to end with some final note. What can you do? So we find that WIKISPEED volunteers typically give about 2 to 8 hours per week. Sometimes they take breaks because they have real lives, that sort of thing. But by giving 2 to 8 hours a week, they actually are changing the world for social good. And it would be really awesome, we feel, if other people did the same thing. And you don't have to do it through WIKISPEED necessarily. Maybe what inspires you is micro-investment for third world countries, or eliminating rotavirus or polio in the world. Doing something that's actually making a difference in the world rather than just watching another episode on TV. Instead of taking that time and actually doing something that's making a difference in the world. And if everyone here did that, that would be so awesome. It would be like a shark high-fiving a gorilla in front of an explosion. Thanks very much.